The next measure of central tendency, or second statistic we're going to look at this term, is median. So median is the measure of the middle of the data set, or the 50th percentile of our data set. We're going to see that idea for median come up again in Module 7 when we talk about box plots and 5-number summaries for data sets. So in order to find the median of the data set, it's important that the data is sorted from lowest to highest. Half of our data is going to be below the median, and half of the values are going to be above the median. Your textbook uses M for median, and it doesn't matter whether it's for a sample population or a sample data set or a population data set. Other ways median is also sometimes denoted is with what's called a tilde. So sometimes X tilde or mu tilde will be used for median in other statistical books. Again, a tilde is something that's written over top of letters. It's like a squiggly bar, okay? But your textbook uses M, and so that's a perfectly fine symbol to use as well. So when we're calculating median, our technique changes a little bit depending on whether we have an odd number of data points or an even number of data points. For an odd number of data values, we rank our data from lowest to highest, and then we pull out the middle value. If you're trying to figure out what rank that value is, if we have n values in our data set, we add 1, we divide by 2. That formula will tell us the position of our values. So when I have 5 pieces like I do here, I have 5 plus 1 divided by 2. 6 divided by 2 is 3, and so I know it's going to be the third value. Or I can just organize it and count and figure out that my median value for this data set is 88. Okay. When we have an even number of data values in our sample, then again we start off by organizing it. So we rank it from lowest to highest. Okay. And then we're going to see 2 values in the middle, or if we try and use a formula, we end up getting an output that's a decimal value. So if I do 6 plus 1 divided by 2, I get 3.5. And so that tells me that my median value is the average of those middle 2 values. So if I have, in this case, my middle ranking values are 80 and 88, my median is neither one of those values, but it's the midpoint between them. So my median would be 84. So one reason why we might cite a median as a central value opposed to mean is that a median is not affected by an outlier value. So in example 2 there is an outlier of 102, but that doesn't pull our median higher. So for skewed data sets, mean is much more affected by outliers than the median is. Okay, so before we move on, take a second, try this practice question, pay attention to how big the data set is, calculate the median, and you can include units in this example as well. So just like for mean, when we know the units that our data is measured in, our median should be quoted at the end with the units as well. Okay, give it a shot, pause the video, and then check your answer. Okay, so for the practice question, your median comes out to 210 pounds. Great job. So the last measure we want to talk about is mode. So mode is a measure of central tendency that just looks at the value that occurs most often in a data set. Sets can have no mode, one mode, or they can have multiple modes. Okay. We can also have modes, data sets that have 2 modes, and we say those data sets are bimodal. And you might have heard about bimodal mark distributions before, and that's when if we were to make a histogram, we actually, instead of having a single hump in our histogram, we might see two humps that are far apart. One of the advantages of using mode in this case is that both the mean and the median might be in the middle, but our mode tells us where those actual higher frequency values occur. Okay, so there's no calculation required for a mode. We just sort the data set or look through and we try and figure out values that occur most frequently. So in the first example, see 108 appears most frequently the same amount of time. There's no special symbol for mode. Some people use MD, or you can just write mode, and so that I'd say the mode is equal to 1.08 for example A. When we look at example B, we see both 80 and 88 appear more than once, and they appear both with the same higher number of frequency. They both appear twice. So this data set, example B, is bimodal. Okay, so when we have a bimodal data set, or any data set that has multiple modes, we're going to use set notation to list the modes. So set notation uses curly brackets, and then we write down the modes, and we write them in order from lowest to highest, and separate them, creating a list with commas. So I'd write the mode is equal to 80, 88. Okay. For the third example, when we look at that data set, no value appears more than once. So there's no mode, there's no most frequently appearing number for data set C. So we'd say there's no mode. And if you wanted to use some nice mathematical notation, you could say that it's equal to the empty set or the null set. So in math, to simplify a set that has nothing in it, we put our curly brackets for the set notation, and then we put a 0 with a line through it, meaning that is empty. Okay. Another advantage of using modes, other than just for bimodal distributions, is we can also talk about modes for qualitative data sets. It's the only measure of central tendency that applies to qualitative data set. So if I have a list of different blood types listed here, and I could talk about what the mode for that data set is, I could say that the mode in this case is O. O type occurs most frequently. It occurs 3 times, whereas the next most frequent is A type, but it only appears twice. Again, nothing too tricky here about calculating it. It's just really about paying attention and then using good mathematical notation as well. Okay. So at the end of the last notes, we introduced the idea of skewness and said that these ideas would come up again. So we touched on this a little bit earlier, but when our data set is skewed or has outliers one way or the other, it can affect where our measures of central tendency occur. If our data set is symmetric, then our mean, median, and mode all occur right in the middle of our data set, and they'll all be nearly equal to each other. Okay? When our data is negatively or left skewed, what happens is the mode tends to be higher than the median, which tends to be higher than the mean. Okay, and when our data is positively skewed, then again, what we see is the mode will be the lowest value, the median will be the next highest, and then the outlier value pulls the mean higher than the rest. Okay. So when we're choosing our measures of central tendency, we have to pay attention to what's going on and the raw data. Whenever possible, we use mean for our central tendency because it takes into account all the raw data. If our data is skewed though, right, if we're talking about average income and we've got a CEO's income included in the mix, then the mean's not going to be good because the outlier, the amount of income that the CEO earns, is going to pull the mean higher and give a false sense about what the average earnings of the workers in the workplace are. And so a median is a better measure of the typical value we expect in the data set. Okay. We use mode only if the data set has multiple modes or if the data set is qualitative in nature. So to finish up here, pause the video, try this practice question, calculate the mean, median, and mode for the data set, and then determine which measure of central tendency best describes the data. Pause your video and then do the work. Resume it to check your answers. When you're writing your answers in, remember to pay attention to the symbols, rounding, and units. Okay, so our mean we represent as X bar, since we've got a sample data set here, is 9.36 days. Notice that I'm reporting my mean to one more decimal place than my raw data was given in. My median, M or X tilde if you want, is 5.0 days. We had 11 values in our data set, so I chose the 6th value. And then the mode is set. It's bimodal. We've got a mode of 2.0 and 5.0 days. Okay, which measure of central tendency best describes this data? Why? The median, the data set has an outlier that makes the mean higher than the majority of the sample values. And although the data set is bimodal, the lowest mode value of 2 is lower than typical and not representative of the expected values. Okay, hope this makes sense. If you have any questions, don't hesitate to contact your instructor or attend their office hours. Good luck on your homework, and we'll talk again soon.